third periodic property is called as electron gain enthalpy. The electron gain enthalpy also changes when we move across the periodic table, that is from left to right or top to bottom. Now, what is electron gain enthalpy? Electron gain enthalpy, it is nothing but the enthalpy change. Again, it is enthalpy means somewhere related to the energy only. So here the definition is, it is an enthalpy change during the addition of an electron to isolated gaseous atom or to isolated atom in a gaseous state. So it is an enthalpy change during the addition of an electron to an isolated atom in a gaseous state. Ionization electron gain enthalpy is generally negative except in certain cases. In certain cases it is positive, otherwise in all the cases it is a negative. Now, electron gain enthalpy. What is electron gain enthalpy? I said it is an enthalpy change during the addition of an electron to an isolated atom in a gaseous state. So, suppose here there is an atom present in a outermost, there is an atom. This is the nucleus for atom, and this is the this nucleus, this atom is already having certain electron in the outermost orbit, and it is already attracting these electron. This is the electron of the same atom present in the outermost orbit, and there is some electron which is present here. This is the coming atom, that is, this electron is not from the same atom. This electron is this is the electron which is coming inside the atom. Now, whether this electron, whenever this electron will be, then when this electron will come closer to the nucleus will start attracting this electron. And if the two bodies are attracting each other, then the process is generally exothermic. Exothermic means when this nucleus attract the electron, as the nucleus will start attracting electron, the certain amount of energy will be evolved, and whatever the energy is evolved is called as electron gain enthalpy. If the attraction is a strong attraction, as the attraction becomes stronger, the more and more energy will evolve. If the attraction is a weak, the lesser energy will evolve. We all know that when the two bodies attract each other with a very strong, if the attraction between the two bodies is strong, the energy evolved is more. So how much energy will evolve, it totally depends upon the attraction between the nucleus and the electron. That means it depends upon the nucleus power, that with what power the nucleus is attracting the electron. If the nucleus is attracting electron with a strong attraction, more energy will evolve. If the attraction is weak, less energy will evolve. Now, whether more energy will evolve or less energy will evolve, it also depends upon the nuclear power, that is power of a nucleus, which is decided by, or which is affected by, again I will say, that is the size of atom, atomic size of atom, number of shells, nuclear charge, shielding effect, configuration, etc. So here the electron gain enthalpy, it is generally negative except certain cases. As I said, in certain cases like for the noble gases, it is a positive. Why it is positive for the noble gases we will see, but generally it is a negative, because here I am saying that this energy goes, it will liberate the energy. During the process, energy is evolved. Now, as I said, more energy or less energy totally depends upon the attraction. Whether the nucleus will attract this electron with the more power or less power, it totally depends upon whether the nucleus is attracting its own electron with the more power or less power. Suppose if the attraction between the nucleus and its own electron is very weak, then in that case the nucleus will not attract the electron which is present from the which is coming from the outside. But if the attraction present between the nucleus and electron is strong, then the electron which is coming from the outside will also be attracted with the strong power. So again, whether more energy, electron gain enthalpy value will be high or less, more energy will evolve or not, it totally depends upon the attraction, whether the attraction is strong or less. More the attraction, more the energy will evolve, and more energy evolved, it means I can say that electron gain enthalpy, negative electron gain enthalpy increases if more energy is evolved. We always use a word negative because the value is negative. In certain cases the value is positive, and so that's why you have to specify whether the value is negative or positive. So when we move from left to right in a periodic table, the ultimately certain things are changes from left to right and top to bottom, and those changes also, the changes, whatever the things are changing, they also produce the change in the electron gain enthalpy. So in electron gain enthalpy, as I said, certain electron is gained. So if an M is an element, it gains electron E and becomes M minus, and during that process whatever the heat is evolved is called as electron gain enthalpy, that is delta Eg, and this value is always negative. Depending on the attraction, the value is decided whether it will be more or less. Okay, now let's see the certain factors which again affect the electron gain enthalpy. The factors are approximately same. So the factors are: number one, the nuclear charge. Is the first factor. Again, whenever we talk about the nuclear charge, this factor, we only think about moving across the periodic table from left to right. So nuclear charge, when we move from left to right, the nuclear charge increases. The nuclear charge increases, that is the power of a nucleus. The power of a nucleus to attract electron increases, and if the nucleus power to attract the electron increases, then it will attract the coming electron with the more power. With the more power, that is attraction will increase, and attraction will increase, that is a more amount of energy will be evolved. So here I can say that when we move from left to right, due to the increase in the nuclear charge, the nuclear power to attract the electron increases, and hence the nucleus attract the coming electron with a strong attraction, and due to which more and more amount of energy is evolved. That means electron gain enthalpy value increases. Negative electron gain enthalpy increases. I'm using the word negative because electron gain enthalpy written in with the negative sign. So negative electron gain enthalpy value increases when we move from left to right. So negative electron gain enthalpy increases. Okay, so this is the first factor, that is a nuclear charge. Now let's talk about the second factor. So here I can say like negative electron gain enthalpy is directly proportional to nuclear charge. More the power, more the nuclear, higher the nuclear charge, stronger will be the attraction, more the energy will be evolved. The second factor which affect the electron gain enthalpy is again the number of shells. Number of shells. When the number of shells changes when we move from top to bottom, and if I'm moving from top to bottom, what will happen? The number of shells increases continuously step by step. And if the number of shell increases, that means the outermost shell is getting away from the nucleus. And if the outermost shell is getting away from the nucleus, there is a attraction between the nuclear effect will goes on decreasing. In that case, if the size increases, then attraction between the nucleus and its own electron decreases. So in that case, the attraction between the nucleus and the coming electron also decreases. And if the attraction decreases, so in that case the nucleus will attract the electron, but since the attraction is a weak, so less amount of energy will evolve. As I said, how much energy will evolve, it totally depends upon the attraction, directly proportional to attraction. More the attraction, more the energy is evolved. So number of shell, when we move from top to bottom, the shells increases, due to which the nucleus power or the attraction decreases, and hence the lesser energy is evolved. So here I can say that negative electron gain enthalpy is inversely proportional to the number of shells, because as the shell increases, the attraction goes on increasing. Then the third factor which affect the nuclear charge, the electron gain enthalpy, and the third factor is shielding effect. Again the same. So shielding effect is the next factor which affect the electron gain enthalpy. What is shielding effect? It is a repulsion which is produced by the inner shell electron to the outermost shell electron. Due to shielding effect, what happens? The effect of a nucleus on the outermost shell decreases. And if the effect of nucleus decreases due to the increase in the shielding effect, that means the pulling power of nucleus to that coming electron will also decrease. And if the pulling power decreases, that is attraction decreases, it means a less amount of energy will evolve. So in case I can say that if the shielding effect increases, then the effect of nucleus also decreases, and hence the nucleus pulling power will decrease and less energy will, and since attraction decreases, so less energy will evolve. So here again the negative electron gain enthalpy is inversely proportional to shielding effect. Then fourth factor is the electronic configuration. So electronic configuration is the fourth factor which again affect the electron gain enthalpy. See, suppose there is an atom having the half filled or completely filled stable configuration. Suppose if an atom is having a p3 configuration, that is half filled stable configuration, having 3 electrons in the outermost orbit in p orbital. So in that case, if an electron is added here, then this orbital or this atom will try to avoid to gain this electron. This atom will not show any interest to gain the electron. The reason, because if the atom having the p3 configuration gains that electron, then its configuration will changes to p4. Here we will get one more electron then its configuration will changes to p4, and p4, once it got a p4 configuration, its stability will decrease. So just to maintain the stability, if an atom is having a p3 or p6 or s2 or d5 configuration, that in that case it will always avoid, or it will not show any interest to gain the electron. And if an atom or the nucleus is not showing any interest, that means the attraction is weak, and so that the less amount of energy will be evolved. So the electronic configuration is the fourth factor which affect the electron gain enthalpy. Stable atom, they always shows very rare, means they do not shows any interest in gaining electrons, so less energy is evolved. So this is about the electron gain enthalpy, and these are the 4 factors which affect the electron gain enthalpy. Now let's see the electron gain enthalpy value for the certain element when we move across the periodic table. Now here again I had considered the second period and its electron gain enthalpy value. As I said, electron gain enthalpy value, it goes on increasing. Negative electron gain enthalpy value increases from left to right from left to right. So here from lithium to this neon, as we move from left to right, the value goes on. So the reason is the electronic configuration. There was a fourth factor which we observed. The fourth factor was the electronic configuration which affect the electron gain enthalpy. Now let's try to understand the electron gain and why it is 0 for beryllium and nitrogen. Beryllium, whose atomic number is 4, so its electronic configuration is 1s2 2s2. It means it have in outermost shell, it have 2s completely filled 2s orbital, and if it is having a completely filled 2s orbital configuration, that means this is a stable configuration, and if you are adding a third electron, then it will show a very less tendency to gain that electron, because after gaining that electron, it's a configuration, after getting that one electron, its stability will, it loses its stability, so it shows a very small tendency, or it shows no tendency to gain electron. And since it shows no tendency to gain electron, no interest to gain the electron, that's why its electron gain enthalpy value is approximately 0. The same thing for the nitrogen. Nitrogen, whose atomic number is 7, its electronic configuration that electron, because after gaining that electron, its stable configuration will destroyed. So in that case, it doesn't like to gain that electron, and if it doesn't like, means if in a case if you are adding the electron, then if the nitrogen is gaining that electron also, then that attraction will be very weak between the nucleus and the electron, because the nitrogen is not showing any interest to gain that electron. And if the attraction is weak, that means a very less amount of energy is evolved, and that's why I can say that nitrogen, this value is 0. In certain books this value is given even positive, and in the, they had written the positive value. The reason was that they have the stable configuration. It was mentioned that they have the stable configuration, and due to that stable configuration, since beryllium and nitrogen do not show any interest to gain the electron, so we have to force them, we have to force the electron to enter into the beryllium and nitrogen, and for that forcing that electron, the energy is needed. So in certain textbook, the beryllium and nitrogen value is even also, and the magnesium is given positive also. Now let's talk about the noble gas. This noble gas is showing the positive oxygen 2s2 2p6, which shows 8 electron in the outermost orbit. So since it is having a stable configuration, so in that case the neon, again the neon will also show no interest to gain that electron. But suppose if you want, if you are forcing a neon to gain the electron, then the electron which enters in the neon have to make a new shell, because after 2p, which next shell comes, then answer is 3s, that is third shell. So in that case the electron which is forced inside the neon atom, they have to make a new shell. So, and since the new shell is formed, so in that case the nucleus of a neon doesn't interact with the electron which is coming, because it is in the new shell. So the attraction between the nucleus and this coming electron is very weak, or there is a no interaction, I can say. So in that case we have to force the electron to enter inside the new shell, and that for forcing that electron some energy is required. So instead of the removal of energy, here the some energy is required to force the electron into the new shell of neon. That's why the value is positive, since the energy is supplied to the atom. Then next, some exception. Now in case of fluorine and chlorine, that is halogen, when we move down the group, the electron gain enthalpy value should goes on decreasing. But in case of here I can say the fluorine value is minus 327 or 328, and this value has become minus 348. That means instead of decreasing, the ionization enthalpy has increases, and the rule says that electron gain enthalpy value should goes on decreasing as we move down the group. Now the question arises that why fluorine electron gain enthalpy is less than chlorine. The fluorine, this have a configuration 2,7, and chlorine also have a configuration, this have a configuration 287. This have two shells, this present in the outermost shell is same whether it is a fluorine or chlorine. So let's see for fluorine and chlorine what happens. This is fluorine atom, which is comparatively smaller in size, and this is the second shell of the fluorine, that is outermost shell. This is chlorine atom. And this is the third shell of chlorine, which is bigger than the fluorine. Nucleus, for this also there is a nucleus, and then the electrons present in the outermost shell. Fluorine have 7 electron, 5, 6 and 7. Similarly the chlorine also have 7 electron in the outermost shell. Okay. Now suppose there is an electron which is entering to the fluorine atom. This is the electron. Now when this electron, the fluorine have the very small in size, and due to which I can say the nuclear power or the nuclear charge is very high. And since the nuclear charge is very high, so it have a very strong tendency to pull the electron inside the outermost shell. So in that case, the nucleus of the fluorine attract the electron with a very high tendency, with a very strong power. So if the nucleus is attracting it with a very strong attraction, then the resultant energy which is given out should be very high. As I said, the nucleus, since the atom is smaller in size, so the nucleus is having a higher nuclear charge. So the attraction between the nucleus and the coming electron will be very high. That's why a very large amount of energy should come out. That means the electron gain enthalpy value should be very high. But what happens here? See, since the sizes are very small, so that here the outermost shell is small, having a 7 electrons. So I can say that on the outermost shell the electron density increases. due to the small size and the more number of electron in the outermost, that is on a shell, the electron density increases. That is a negative charge on the shell increases. So due to which when the electron enters, when the nucleus attract the electron, since the electron density is very high, so that coming electron face some repulsion from this inner electron, that electron which is present in a shell. It faces some repulsion, and due to that repulsion, what happened, the ultimate or the effective attraction between the nucleus and electron decreases. This coming electron doesn't feel the net or the total attraction of a nucleus because of that repulsion, and because of that repulsion I can say the attraction decreases, and attraction decreases, that is a less amount of energy is evolved. Now what happens in case of chlorine? Chlorine, the size is bigger, having a 7 electron again. Here this is the electron which is coming from the outside, that is some other atom. Now when this electron comes, the nucleus is again attracting this electron. Now when the nucleus start attracting electron, and the attracting power of the nucleus, here the nuclear power is less than the nuclear power of the fluorine. But here when the electron is attracted, such type of repulsion is not the repulsion which was feel by the coming electron in case of fluorine due to the small size and high electron density. Such type of repulsion is not feel by the coming electron in case of chlorine. And since the coming electron is not feeling any such type of repulsion, so the effective nuclear charge is very high in case of chlorine. That means here the attraction is strong, and that's why the more amount of energy is evolved. So in case of fluorine, the energy evolved is only -328, while in case of chlorine, the energy evolved is less than fluorine. Okay, the value is in case of chlorine, the energy evolved is more than chlorine, that is -348.3. The reason, so the question may be asked that the fluorine and chlorine, whose electron, why the fluorine electron gain enthalpy is less? The simple answer, because in case of fluorine the size is small, and that's why the net effect, the coming electron feels repulsion, and due to which the coming electron getting some repulsion, and due to which I can say the effective nuclear charge decreases. Okay. Now here like ionization enthalpy, first ionization enthalpy we did, then we did second ionization enthalpy. Similarly here we also have the first electron gain enthalpy, second electron gain enthalpy. This is known as successive electron gain enthalpy. Gain enthalpy. Successive electron gain enthalpy means how the electron gain enthalpy value changes, means where for removing of when more amount of energy is absorbed or evolved, when the first electron is gained or second electron is gained. Let's see the value with the help of some example, like oxygen. When oxygen gains first electron, it becomes O minus, and its electron gain enthalpy, the electron gain enthalpy is for oxygen, it is -140.9. When the same oxygen is added with some another electron, when the second electron is added to the same oxygen means after gaining a one electron it is O minus. So when this second electron is added to this anion, it becomes O2 minus. And here the electron gain enthalpy, delta H, is plus 780 kilojoule. And this is kilojoule also. This is also kilojoule per mole. Okay. So when the first electron is added, this is the value. When the second electron is added, this is the value. Now in this case, you can observe that when the first electron is gained, a certain large amount of energy is evolved. This -140.9 is a large energy which is evolved by the oxygen. But when the second electron is added, then instead of losing energy, some energy is produced to it. The question arises that why second electron gain enthalpy of this oxygen is positive. Not only for the oxygen, for other elements also generally the second electron gain enthalpy is positive. Means second electron, now why it is positive? Because the electron is forced to the atom. Here the electron or O minus, O shows the interest to gain that electron. But when the electron is added to this O minus doesn't show any interest to gain that electron, or that gain of electron is opposed by the same charge, that is O minus on the anion, and the electron also carry negative charge. So in that case, since it carry negative charge, so electron, when electron is forced or when electron comes here, this negative charge repel it, and so the electron is not gained. So in that case, the electron is forced to enter inside the O minus, and that forcing of electron inside the atom is done or is achieved by supplying some amount of energy, and since here the energy is supplied, that's why the value is positive. So here this value is positive. That is second electron gain enthalpy. Not only for this, here also I can write for sulfur. For sulfur, the first ionization enthalpy is minus 200. But for the same sulfur, the second ionization enthalpy I can say it is a 590 kilojoule. The same thing I can say for selenium. The first ionization enthalpy is a minus 195. But the second ionization enthalpy for this is also 420. So second ionization enthalpy is generally positive because the anion doesn't attract the coming electron because of the same charge. So in that case, the electron is forced into the atom by supplying certain amount of energy. So this is about the electron gain enthalpy.